So the next question is question number 12. The adjoining figures are shown three particles A, B and C which are equally charged. The force on B due to A is 2 into 10 power minus 6 Newton. Then find for each diagram the force on B due to C and net force on B. So first of all, we see the first diagram. In the first diagram, there are three spheres A, B and C. The force between A and B is given. It is, the value is given in the question. This is 2 into 10 power minus 6 Newton. We just show the force by this arrow. A is applying force on right hand side, and then we apply the formula. Force FA is 9 10 power 9 q square by distance square. When we apply the formula, the distance is 0.015 meter, which is force distance between A and B. Now C is applying force on B towards left. C will repel B towards left. Both are equally charged. This is positive, positive, both positive charges repel. So finding the force due to C on B, apply formula 9 10 power 9 Q1 Q2. Now Q1 is Q, Q2 is also Q. Distance is 0.010 square. Divide both the equations. 200.6 upon FC is equal to 9 10 power 9 cancels out, Q square cancels out, we get 2 by 3 whole square, that is 4 by 9. On cross multiplying, the value is 4.5 10 power minus 6 Newton. In the first diagram, the force by C, force on B due to C is towards left, and the value is 4.5 into 10 power minus 6. The same solution will be for the second diagram also. The answer will be 4.5 into 10 power minus 6 Newton, but this time the force applied by C on B will be upwards. So for the second diagram, the value is same, but force is upward. In the first diagram, we observe that both the forces, one force is given in the question, other force we have calculated, both are opposite to each other. When forces are opposite, then according to the principle of vector, we subtract smaller from bigger. So we get the answer by subtracting the values. 2.5 10 power minus 6 Newton, the direction will be towards left, because the force acting towards left is bigger than the force acting towards right. But the second diagram, the forces are making angle 90 degree with each other. So when the forces are acting 90 degree with each other, we cannot add or subtract. We have to find the resultant force by using FC square plus FA square. Force due to A plus force due to C, F1 plus F2, or A square plus B square, we can say. Put the values and answer will be 4.925 10 power minus 6 Newton. The direction of the force will be found by making a parallelogram, making angle theta. Tan theta is perpendicular upon base. The perpendicular is representing this force and the base is representing FA. Put the value, it will be 2.25. So theta is tan inverse 2.25. We can calculate the value if we have scientific calculator to find the net force. Now before moving further, we have to study a new concept or a topic which is called equilibrium. The simple meaning of equilibrium is that the net force or the net torque acting on a body is zero. But if there are particles, the net force on them should be zero. The point where the net force is zero is called equilibrium point or null point or neutral point. Now, if there are only two forces acting on a particle, only two forces acting, then for equilibrium, the forces should or they must cancel each other. They will cancel each other only. Number one, they must be equal. If they are equal, then only they can cancel each other. Second, they must be opposite to each other. Now see, let there are two positive charges Q1, Q2, and the third charge Q is placed at a point on the line joining them so that no force acts on it. In the first diagram, there are two charges Q1, Q2. A third charge Q3 is placed between them. Q1 repels it towards right, Q2 repels it towards left. There are two forces, they are opposite, and they are opposite, they can cancel each other. The distance of the third charge from the first is x, and the distance of third charge from the second is r minus x. Say the total distance is r. But if the charges are of opposite sign, in the first diagram, there are Q1, Q2, one is positive, other is negative, and Q3 is placed between them. Suppose Q3 is positive, Q1 will repel Q3, and Q2 from the other side will attract, negative charge attracts Q3. So on Q3, the two forces will be in the same direction. If the forces are in same direction, they will not cancel each other. The forces must cancel each other, then only the net force will be zero. So we cannot place Q3 somewhere between these two. So where should the Q3 be placed? We place Q3 outside the line joining the charges. So Q1 is positive, it is repelling Q3, Q2 negative, attracting. At this place we observe that the forces are opposite to each other. So this is the place where the net force can be zero. Now we have to note down one thing, that if there are two like charges, as in the first diagram, the null point or the neutral point is somewhere between them. But for unlike charges, second diagram, the null point is outside the line joining the charges on the side of a smaller charge. On the side, suppose Q1 is smaller and Q2 is bigger, then this point will be on this side, because Q1 is smaller. If Q1 is bigger but it is farther from Q3. Q2 is smaller, it is nearer. So both can apply forces which can cancel each other. If Q1 is bigger and it is nearer, the force of Q2 is bigger and nearer, then the force of Q2 will always be greater than the force applied by Q1. So we have to note that the null point will be outside the line on the side of a smaller charge. So for the first diagram, we can write the formula. Force number 1 equal to force number 2. First diagram at the top, Q1, force between Q1 and Q3 is 9.9. Q1, Q3 upon distance from the diagram is x square. Q2, Q3, 9.9, Q2, Q3, distance from the diagram is r minus x. In this diagram, the second diagram, when we put the value of f1, it is 9.9 Q1, Q3 upon r plus x whole square, and 9.9 Q2, Q3 upon x square. Q2 must be less than Q1, means on the side of a smaller. If Q2 is bigger, the null point will be on this side. Clear? Now we come to question number 13. 2 point charges plus 1 microcoulomb and minus 0.25 microcoulomb are 0.4 meter apart in air. Find out at which point on the line joining them a third charge must be placed so that no force acts on it. Now see the diagram. 1 microcoulomb, 0.25 microcoulomb. The null point will be outside the line on the side of the smaller charge. Distance r, that is between the two charges, 0.4 is x. Put the formula 9.9. Q1 is 1, Q2 is q. Distance is 0.4 plus x whole square. Similarly, 0.25 applies force of attraction on q, and Q1, Q2, 0.25 into q, micro is 10 to minus 6, distance x square. Cross multiply. Now do not open the bracket, because then it will become a quadratic equation. Just take a square root both sides. It will become 1 upon 0.4 plus x. On the right hand side, 0.25 under root is 0.5 upon x. Now cross multiply, we get the value of x is 0.4 meter. So 0.4 meter from smaller and 0.8 from the bigger. Now we come to question number 14. 2 point charges 9e and e are placed at a distance of 16 centimeter. At what point between them a third charge be placed so that it remains in equilibrium? The solution is here. There are one charge is 9e, other is e. Both are positive. When the sign is not given, we can take that both are positive. Distance is 16 centimeter. When the charges are positive, the null point will be somewhere between them. Distance is x from one side, 16 minus x from the other side. The first force is applied by 9e on q. The second force will be applied e on q, and both the forces must cancel each other. So the first force which is between them is 9.9 q1 q2 upon x square. The second force between these two, 9.9 q1 q2 upon 0.16 minus x 16 centimeter will be converted into meters to make it an MKS system. Cancel out the terms which can be cancelled out, and don't open the bracket, just take the square root both sides. 3 upon x, 1 upon 0.16 minus x, cross multiply, we get x is equal to 0.12 meter or 12 centimeters. Now question number 15, 3-point charges q1, q2, q3 are in a line at equal distances. Q2, Q3 are opposite in sign. Find magnitude of and sign of Q1 so that net force on Q3 is 0. First make the diagram. Q1, Q2, Q3 equal distance R in a line. Q2, Q3 are opposite in sign, that is given in the question. If Q2 is positive, Q3 is negative. Otherwise, opposite can also be taken, but we have taken Q2 as positive, then Q3 is negative. Now, Q2 will apply force of attraction on Q3. The question says that force on Q3 should be 0. So Q2 will attract, because it is given that these two are opposite in sign. So Q2 will attract Q3. Now, in order to make the net force on Q3 0, the first charge must repel it. Otherwise, the net force will not be 0. For the process of repulsion between Q1 and Q3, both should have same sign. So if Q3 is negative, Q1 should be negative. While making the diagram, we come to know that the Q1 is negative in sign. Now there are two forces. We have to make the forces equal. Only then they will cancel each other. Force number 1 is between Q1 and Q3. 9 and 9 Q1 Q3 upon distance from the diagram is 2r whole square. Second force is between these two, Q2 Q3, distance is r square. Cancel out the terms and we get Q1 for Q2. Negative we already know while making the diagram. Negative means the sign of Q1 will be same as sign of Q3. If Q3 is positive, Q1 will be positive. If Q3 is negative, Q1 will also be negative. So the sign of Q1 will be same as Q3, and the value of Q1 will be 4 times Q2. Now come to question number 16. It says that ABC is an equilateral triangle of side 10 meter and D is the midpoint of BC. Charges of plus 100, minus 100 microcoulomb and plus 75 microcoulomb are placed at B, C and D respectively. Find the net force on 1 microcoulomb charge placed at A. So first we make the diagram. ABC is a triangle. D is midpoint of BC. 100, 75 minus 100 BCD पे रखे हैं and 1 microcoulomb charge is placed at A. We have to find the net force on the particle placed at A. The particle placed at A will experience 3 forces. First force will be applied by B. B will repel A, that is FB. C will attract A towards itself because it is positive and it is minus 100 negative, and D will repel it in upward direction. There are 3 forces. We have to calculate the values of 3. FB is the force between these two. So 9 10 power 9 Q1 Q2. Q1 is 100 microcoulomb, Q2 is 1 and distance is 10. It becomes 9 10 power minus 3. FC is the force between A and C. The value will be same because Q1 is 100, Q2 is 1, distance is 10. FD is the force between 75 and 1. Answer is 9 10 power 9. Q1 is 75, Q2 is 1, and the distance is this dotted line between A and D. By Pythagoras theorem, this side is 10, this is 5, so this side will be under root 75 meter. On solving it is 9 10 power minus 3 Newton. So we come to know that all these forces are 9 10 power minus 3 Newton. We have to use vector. We cannot add forces directly. First method is using law of parallelogram. For law of parallelogram, we have to select any two forces. We have selected FB and FC, and the angle between them is 120 because it is equilateral triangle. So inner angle will be 60 degree. The angle between FB and FC will be 120. We find the net force of these two, FB and FC, from this diagram, B and C. The net force will be somewhere between them, bisecting the angle between them because both are equal in magnitude. The value of we are representing this force by the symbol FBC using law of parallelogram. Under root A square plus B square plus 2AB cos theta. First force is square, second force is square plus 2 into first into second into cos 120. Put the values, and on solving we come to know that the value of this is also 9 10 power minus 3 Newton. So now FB and FC have become converted into a single force. Now FD is acting upward. In the second diagram, we select the resultant of first two and FD, which is remaining. These two are perpendicular to each other. So we have to calculate the net force. When the forces are perpendicular, we apply a formula similar to Pythagoras theorem, because cos 90 term will become 0. So this is 9 10 power minus 3. We have calculated the value. FD is already 9 10 power minus 3. Calculated the first step. So the total force is 9 root 2 10 power minus 3 Newton. Since both the forces are equal, the resultant will bisect the angle between them. Total angle is 90. This is 45. So it will make 45 degree with horizontal direction, or with a line which is parallel to BC. Now the second method is called addition by resolution. In this method, we make the diagram and we resolve all the forces in two components. This is FB. So the force FB is resolved into two components: horizontal component cos 60, vertical component sin 60. FC, two components: horizontal cos 60, vertical sin 60. Now we have to find the total force along x-axis. It is discussed, the method is discussed in the previous video. Horizontal force FB cos 60 plus FC cos 60, it is 9 10 power minus 3 cos 60, half plus half, it is 1 10 power minus 3 Newton. 9 10 power minus 3 Newton is the value of net force along x-axis. Net force along y-axis, there are three forces: FD, FB sin 60 and FC sin 60 downwards. So downward force will be represented by negative FD plus FB sin 60 minus FC sin 60. These two are equal, they will be cancelled out. Again it is 9 10 power minus 3. That final total force is under root fx square plus fy square. The formula is given in the previous previous video. It is 9 10 power minus 3 root 2 Newton, and the direction will be tan theta is Fy upon Fx, which is 1. So theta is 45 degree with x-axis. Now the last question is question number 17. It says that at each of corners of a square of side A, charges plus q coulomb are placed freely. What charge should be placed at the center so that the net force on the system is 0? The whole system is in equilibrium. We have made a diagram where there is a square having four charges: small q, small q, small q, small q at the four corners, and the center charge is capital Q. We have numbered these charges. First charge is at the top right corner, second charge is the top first charge is at the top left corner, second number is bottom right corner. Bottom left corner is charge number 3, and the middle charge is charge number 4. We have selected one charge at the right top corner. Now the right top corner charge experiences four forces. Charge number 1, Q1, applies the first force F1. Q1 will repel, this first charge will repel this selected charge towards right. This bottom charge will repel it upward, F2. This charge, third one, will repel it, F3, towards, making angle 45 degree. And the middle charge will repel F4, F3 and F4 in same direction. We have calculated the values of charge. In place of 9 10 power 9, we have written K. So F1 is K into Q square by R square. A square. A is the distance between first charge and the selected charge. F2 is also K into Q square by A square. F3 is the force applied by Q3. So the distance between the two corners is A root 2. So force is A root 2 square. It becomes 2A square. And when we calculate the F4, that is force between middle charge and the corner charge, it is 9 10 power 9, and in place of 9 10 power 9, I have written small k. Q1 is small q, Q2 is capital Q. Distance is A root 2 by 2 whole square, which is half of the diagonal of the square. So it becomes a square, on squaring it becomes 2A square by 4. So on solving it becomes 2 small k small q capital Q upon A square. The first method is again law of parallelogram method. We select two charges F1 and F2 first and try to find the resultant F12. F12 is F1 square plus F2 square because they are perpendicular. We cannot add them directly. F1, F2 both are equal, so k q square upon a square common, and the total value is k q square upon a square into under root 2. The second step is to find the net force. To find the net force, we make the second diagram in which F12 is the resultant of F1 and F2, which we have calculated in step 1. And F3, F4, all are in same direction. When the forces are in same direction, they can be added directly. So the total force is F12 plus F3 plus F4, but in the question it says that the system is in equilibrium, so the net force will be equal to 0. So F12 plus F3 plus F4 equal to 0. We put the values of F12 from step 1 and F3 and F4 from the top right side we have calculated, and on solving we get capital Q is minus Q by 4 bracket 1 plus 2 root 2. The second method is called resolution method. In this method we we draw all the forces F1, F2, F3, F4. Since the net force is 0, so the x component of all forces should be 0. X component of first force is F1 cos 0. F1 is making angle 0 degree with x-axis. F2 is making 90 degree, F2 cos 90. F3 is making 45 degree with horizontal, so F3 cos 45 is the horizontal component. F4 is also making 45 degree, F4 cos 45. Total is 0. Put the value of F1, F2, F3 and F4 from top, and on solving we get the value of capital Q equal to minus Q by 4 into 2 root 2 plus 1. So this is the solution of question number 17. So in this way, up to question number 9, there are simple questions where the Coulomb's law formula can be applied once or twice, but after question number 9, there are questions in which we have used law of parallelogram or resolution method, means the extensive use of vector is there. The method for applying law of parallelogram, or the method of adding two forces or three forces by resolution method and by law of parallelogram, it is given in the previous lecture. So before solving question number 10 to 17, if you just revise the topic from the previous video, that is how to apply superposition principle, then it will be easier for you to understand these questions. Best of luck. Thank you. Jai Bharat.